Start recording. And welcome everyone to the community call. Thank you for joining, taking the time to join us. This call, this is the last one for September. We have these every 2 weeks, as you know. Today on the agenda, we got a few things. We're going to start with some presentation and demo from the recently announced integration between Dapper and the Azure API management service by Max and Vlad. They're going to cover that. After that, a couple of things that are coming up in the release, the upcoming release of 0.11, service invocation access lists and secret scoping. So maybe a few words about that release. We are really at the kind of last few yards of that milestone, and you're gonna see that release coming out this week. So look out for that. It's going to include these two features, and we also covered a few in the past community calls, like declarative subscriptions for PubSub, and a few other things like service invocation across namespaces. So a lot of good stuff coming in from for that release. You will see in moving forward that our focus is going to be more on the fundamentals of Dapper, so things like fixing bugs, making sure we address all the security issues that we find, and including more testing and things like that. As always, you can see that in the issues that we're tracking across the different repos and in the projects that are available in our public, so you can see what we're doing there. With that, let me kick it over to Vlad for the first segment about the recent integration with APIM.
Thank you, Ori. I'm just trying to share my screen here. Here we go. Can you guys see it?
Yeah, we see it.
Awesome. All right, so I'm Vlad Vinogradsky. I'm a product lead for Azure API Management. Very excited to be on this call and to represent the API Management team and share the result of the collaboration between the Dapr team and API Management team over this summer. So I'm guessing the audience is closely familiar with Dapr, but I'm also assuming that some of you may not be super familiar with API Management. So I'm going to spend just a few minutes explaining what Azure API Management is and does, and set the context for the integration with Dapr, after which Max will show you a demo of Azure API Management interacting with Dapr applications. So API providers, our customers, use Azure API Management to abstract and expose data and services located across clouds and on premises as stable and discoverable API facades tailored for specific outside-in consumer use cases. Using a control plane via Azure Portal, Visual Studio Code extension, or a number of other tools that operators use, API providers can easily create an API facades directly from a web functional logic apps, import them from standard definition formats like OpenAPI, or even define them manually. API providers decouple API and backend services lifecycles with revision and versions features, and secure, protect, transform, and accelerate the APIs with around 50 out-of-the-box policies that are enforced in the gateway. Azure API Management policies are different from Azure policies, and they are basically encapsulations of common functions, such as throttling, caching, token validation. So app developers use Developer Portal to discover APIs, learn how to use them, and make the first successful call literally within seconds without writing a line of code. All three components I just mentioned come in every service instance in Azure Cloud. In addition, the Developer Portal and the gateway can be self-hosted by customers in their own environment. In particular, self-hosted gateway is packaged as a Linux-based Docker container and therefore can run anywhere Docker is supported, including Kubernetes. So self-hosted gateway connects to Azure API Management Service in Azure via an outbound connection to receive configuration and upload telemetry. Azure API Management has excellent support for a variety of Azure services that customers use to implement their backends. Last week, we announced an addition of support for Dapr. So how does that integration work? So let's go to the next slide. So here, on this excellent diagram created by Mark Chmarny, whom I'm sure you all know, explains how this works. So for now, this integration is available in preview in the self-hosted gateway. So enabling it is a two-step process. First, you turn self-hosted gateway into a Dapr application by adding Dapr annotations and deploying that gateway into a Dapperized container. I'm sorry, cluster. Of course, Dapperized means that it just runs Dapr system components. So after that, you apply one of the three policies that we specifically created for this integration that allow gateway to interact with the Dapr runtime in a sidecar. And this Dapr sidecar will be doing all the heavy lifting of communicating with various other Dapr applications. So these policies allow you to invoke a service, send a message to a pub subtopic, or trigger an outbound connection. So now with this Dapr integration, Azure API Management can be used to publish Dapr applications APIs across Kubernetes clusters, alongside with the rest of APIs in the organization to internal and external consumers. So with that, I'm going to hand it off for Max, who can show you a demo. Thank you.
Hi all, my name is Maxim Kim. I am an engineer on Azure API Management. And do you see my screen?
Yes.
Hello.
Yeah, we see it.
Cool. So for today's demo, I have a AKS cluster, which is a managed Kubernetes running in Azure with Dapr runtime installed version 0.10. And I have pre-created Azure API Management Service in cloud with support for self-hosted gateways, and one is already pre-created. So for my application that implements some useful functionality that we want to expose through public API, I'm going to use application that is part of Dapr samples, again created by Mark. This is very simple echo application that echoes back payload of request and response with gRPC interface. So it's very simple deployment with Dapr annotations. I'm gonna just deploy it on my cluster. Okay, and then I'm gonna deploy next to it API Management Self-Hosted Gateway. It's the second deployment. I'm using beta image because, as Vlad mentioned, the Dapr function integration is in preview, and there's a couple of configuration parameters. One is the address of configuration endpoint in the cloud, where the self-hosted gateway is gonna connect to, and which we're gonna use to control the behavior and configuration of the self-hosted gateway. And there is credentials to authenticate against this configuration endpoint. These credentials are pre-created, so I'm deploying gateway as well. And next, we're gonna go to the Azure portal, to this API management service, and gonna define some demo API. So let's just call it demo. We don't have any backend to upstream by default, where we're gonna forward requests to. And what I'm gonna do is I'm gonna expose this API to our self-hosted gateway in addition to managed gateway, which is running in the cloud. I'm gonna disable authentication and create one operation. Let's call it create order, and that's gonna be available over post to orders collection. Okay, so we have API created. I already have load balancer type service with public IP, so I can access my self-hosted gateway using public IP. So let's see if it's running. Okay, so we have health endpoint reporting status service operational. And let me invoke this endpoint pretending like I'm creating an order in the system using public API. So I get 500 here because like gateway is confused. It doesn't know like where to forward request to. So since I want to send I want this request to be forwarded to the application, gRPC application I just deployed. And because both of them are deployed into the same Dapr cluster, and they both are Dapperized, so just like this eco application, this gateway application, it also has Dapr annotations. So what I need to do to make this gateway to forward the request to this application is to drop first of the policies that Vlad mentioned that allows for service-to-service invocation. So it's called set backend service, and what we tell here is that we're going to forward request to Dapr application. The ID of the application is eco-service. It is the same as we have in Dapr annotations here. And the method we're going to invoke is called eco because this is the only method that this application supports. It's called eco. So let's save it, wait for a couple of seconds, and repeat the call. Okay, so we get back 200 and it just echoes back the response. So let's add one more thing, pretend it really creates an order and returns back order ID. So it drops some policy, small policy in outbound that in the response header, it returns order ID, which is just unique ID of the request. And now we see that it returns back order ID, different ID every time. Okay, now let's assume that once order created, we want to drop a message to some message broker to notify other microservices that order was created. So since we're on Dapr, it's very convenient to use Dapr PubSub component. I already have one pre-created. It is backed by Redis. Very simple deployment you can see here. So in order to do that, I'm adding one more policy, again, very simple and declarative way, that says that once we receive response from the backend, we want to publish message to a PubSub, and this is the name of the PubSub. And also we need to specify the topic. In our case, topic is orders. And the message we're going to drop is order created : and the ID of the order. Let's save it. And let's repeat request. So we're getting same response, so nothing changed for the client. But what happens is that underneath is that gateway also invokes Dapr sidecar to publish the message. And in order to make sure it really happens, I'm gonna start one more pod in the same namespace with the Redis CLI. I'm gonna connect to the Redis server. And since Dapr PubSub integration, in case of Redis, is implemented using Redis streams, what I'm gonna do, I'm gonna block on the reading Redis stream called orders and see if I can get any message. So let me send this request again. And we see that we are able to get the message. And its ID is the same ID we are getting in the response header. So let me try again. Yeah, and we are getting another order message here. Okay, and the last thing I want to show is a support for binding invocation. So imagine in addition to publishing message, we will also want to keep track of last created order in some persistent store. For the store, again, we want to use Dapr component. Now it's binding, and it's backed by the very same Redis server. So you can find the configuration here. And in order to do that, I'm adding one more policy called invoke Dapr binding, where I define which binding I want to invoke, demo binding. This is the name here. Operation name is created by default. Since it's backed by Redis, there's required metadata that I need to provide is called key, which value is the name of the key, which Dapr gonna create in Redis, and the data is request ID again. So I'm saving this one. Again, nothing should change for the client. Yep, but let's see if Dapr is able to create the key in Redis. So I'm switching back to the Redis CLI. Let's make another call and let's try to get this key, ask order ID. Yeah, so we see that it creates order ID key with a value of order ID, just like the one that was returned by self-hosted gateway. And if I change it, I see that the key changes here. So these are, three features of integration that we announced in the preview version of self-hosted gateway: service-to-service invocation, publish subscribe, and binding invocation. And with that, I think I'm done. Thank you.
Great, thank you, Max and Vlad. So if anybody has any questions, feel free to drop them in the chat window or raise your hand and we can unmute you. But I'm not, oh, I just see something popped up. Will there be support for non-self-hosted Azure APIM on Dapr enabled AKS integration? I know, Vlad, if you want to take that one.
Yeah, I will do it.
Oh, you
I was
can
just trying to type it, yes. So yeah, I mean, we are still working on the plans for support for Dapr in our managed gateways, but for AKS, as long as you deploy self-hosted gateway into the same cluster, you can certainly use Dapr there as well, Dapr integration there as well. So that's basically the answer to that. Make sense?
Great, thank you. And feel free to drop more questions and we can maybe come back to them in the Q&A at the end of the session. With that, I'll kick it over to Yaron for service invocation access lists.
Okay, I will share my screen. Let me know when you can see it.
Yeah, we see it.
All right, so hello everyone, and now we're going to be exploring a new feature coming up in Dapr 0.11, which is called access lists or allow lists for the service invocation API. So if you're using Dapr today, you might know that Dapr has support for in-transit encryption of your traffic from one Dapr instance to another. Dapr does that by having each sidecar, and this is a Kubernetes example, but it works outside of Kubernetes too. Dapr does that by having the Dapr sidecar talk to a component called Sentry, which is a certificate authority that generates a workload certificate for that Dapr instance. And then, so when you're using service-to-service invocation, Dapr presents the client-side certs and the server certs to the other Dapr pod. And there is a mutual handshake going on and basic authentication, and then your traffic is encrypted in transit. Now, we've had this feature since 0.4, I think, for about a few months now, and we've been getting asks to support access lists, so provide an identity framework and features that more resemble things like you'd find on service meshes like Istio and Linkerd, and service meshes that implement the SMI. So the ability to specify, for example, which applications can access which applications and on which methods, both for HTTP and gRPC. So what we've done and what you're going to see in 0.11 is basically an extension of that. So now a Dapr pod can basically come up and it'll get the same workload certificate, but it will also get something inside the certificate as a SAN extension called a SPIFFE identity, which I'm going to touch on a little bit later. This identity is basically a strong identity that's issued by the certificate authority to each one of the Dapr instances. And thus that identity is carried over during the mutual TLS handshake where one Dapr instance talks to the other. And so we've also introduced an access policy, which we're going to see in a sec, that can be referenced by a Dapr application. So those of you who are already using Dapr, you know that Dapr has a configuration object, a configuration YAML that's applicable both to Kubernetes and non-Kubernetes environments, where you can basically define a whole bunch of things like whether or not to enable or disable mutual TLS, enable or disable metrics and tracing. And now there is basically an access policy section to it, where you can define advanced access capabilities. And really what underlines this entire thing is the concept of trust domains. So a trust domain is really a logical group where different applications can be associated with a single trust domain. And by default, applications in a single trust domain will trust each other, but they will not trust incoming connections from applications in different trust domains. So you can think of trust domains as a really powerful way to basically create, groups of domains, for example, in a single namespace in your Kubernetes cluster. Or you can create a trust domain where, for example, here on the left, app1 and app2 are applications in the same trust domain, but they're in different namespaces. And namespaces, I will just remind again, is something that's supported both on Kubernetes and also in self-hosted modes. But you can also think of trust domains as something that goes across the cluster boundary. So for example, this might be an app1 running on Google Cloud in GKE, and app2 might be running on AWS, on an AWS Kubernetes cluster. And they, as long as they have the same root certificate issued to them by the Sentry service running in their clusters, you will be able to do service-to-service invocation. And this is what the configuration looks like. So I'll walk you through this. This is sort of similar to what you'll find, for example, if you're aware of Istio authorization policies. So this is a configuration and it has a name, myconfig. Each Dapr application can reference that configuration using an annotation, or if you're running Dapr self-hosted, you can basically point the Dapr daemon process to the configuration object. So we're defining an access control here, and we have a default action of deny, which basically means deny traffic from any type of applications besides the ones that I'm defining here in policies. And here we're setting the trust domain for my application. By default, it's public, but you can set the trust domain of your app to be whatever you want. And here we have a policy that basically says, hey, for my application, have a policy for an application with an ID of app1. And this is app ID, by the way. And the default action for this one is deny. So accept traffic for app1, by default deny everything. It should come from the public trust domain, and you can only get requests from applications with the ID of app1 from the namespace of Dapr tests. And here we have a bunch of operations that have specific actions attached to them. So here we're basically saying app1 is not allowed to invoke the orders method with a post verb, but it is actually allowing the get operation here. And so you can create these really rich combinations of operations and default actions that basically specify which applications can access your application from which namespace, which logical trust domain, and which method and HTTP verbs. If we were having a gRPC application, you would have removed the HTTP verb because there is no concept of an HTTP verb from the user-facing point of view of gRPC, and you would basically just give in the name of your gRPC method. If you know ISTI authorization policies, there is no need in Dapr to basically come up with the entire package name. So you don't need to have the package name and then the namespace and then the service name for the gRPC operation. You can basically just give it the name of the method that you have inside your application. And so we've asked ourselves, what would be a good framework to provide identity for Dapr? Are we going to create our own, or is there something that we can leverage in the cloud native ecosystem that we can actually use? And so we talked to our friends from VMware, and they were pointing us out to Spiffy. So Spiffy is an identity framework. It's a CNCF project. It's basically a specification for standardizing the issuance of identities through JA tokens or X509's certificates. Dapr uses certificates and not JA tokens, and this is also the recommended way to carry out those identities. Spiffy comes with its own issuing server, which is not required. It's called Spire. You can go check it out. It's pretty nice. Dapr, like Istio and like Linkerd and Consul, has its own certificate authority. So like Istio and a bunch of other projects, Dapr now issues Spiffy standard IDs that gets injected as extensions into the certificates that are issued by Dapr. And so we chose to use Spiffy. Which sort of gives us this nice standardized way to carry identities over. And if we're thinking about, future integrations, you might think about having Dapr being able to participate in mutual TLS operations of other service meshes that also carry over Spiffy identities, which is kind of nice. So the Spiffy ID for Dapr looks like this. It's basically an ID with a trust domain. And this really does not mandate anything from the user side. This is me giving you like inside details about how it's done. So whenever you have a Dapr application that comes up, either in a Kubernetes namespace or not, and you configure a trust domain for it and a namespace, the Sentry Certificate Authority will issue a Spiffy ID with this URL format. And that basically gets carried over and is authenticated by the Kali Dapr sidecar. And I'm going to kick it off to Vinaya now for a demo of this. So to you, Vinaya.
Thank you, Yaron. So let me share my screen. Okay. Let me know when you can see my screen.
We see it.
Okay. So I'm going to be demoing the access control policy feature on the Hello Kubernetes application that we all are familiar with. So here is the Node app configuration that I'm applying. And here is the Python app configuration that I'm applying. So now here Node app is the called app. And like Aaron mentioned, we are going to apply the access control policies on the called application side. Here Python app is the calling app. So what I'm doing here is to the Python app, I'm assigning a trust domain of value my domain. And these policies are not really used on the caller side, but I'm just assigning it a trust domain value of my domain.
Hey,
now
Vinaya, is it possible to enlarge the fonts a little bit?
Okay, sure. Better?
Yeah.
Okay. So, yeah, so on the called application side, what I'm doing is I have the access control policy at the global level as deny. And at the app level also I have it as deny, but on a specific operation and a verb, I have it as allow. Now here always the most specific policy that is matched will take effect. So now since this is allow, when the in the Hello Kubernetes application, when the Python app makes a call to the Node app, the call should be allowed. So let's apply this configuration. So here, if you check this, so I'm adding a Dapr annotation here and applying that configuration here, and similarly to the Python app. Now let's apply this here. And we expect that everything should be allowed. So this is the end application. Okay, and we see, okay, I think I have some issue with my Redis setup, but that's fine. So the node application is getting the request coming in from the Python side. Now let's go and change this configuration here. So I'll be changing this action to say deny, because we expect this to take effect, and just for clarity to see if this is the one that's getting allowed, allow everything else. Okay. And now let's apply this new configuration here. Okay. So if you see here, I don't see any app requests coming in from the Python side anymore. Now I have to show you the Dapr logs. I added a few extra debug logs. So I see here that access control policy has denied access to this Python app and the verb post. And I added extra debug log here just to show you that the spiffy ID that the Python app is coming in has like the trust domain as my domain, the namespace as default, and the app ID as Python app. We match that against the access policy specified in the node app configuration and accordingly match the most specific policy. Now let's change this a little bit and see what happens if I, yeah, I'll keep this as allow. I'll change this method name to say something that doesn't exist. And so what I'm doing here is basically when we try to match an operation, we won't find anything. So in this case, but we do find the Python app. So the default action at the app level should take effect. So let's see how that is working. Let's apply that here now. So like as you can see here, that's the only policy, the app level policy that's denying. So we should still see the node application not getting the request. So see, we again see this policy getting denied because now the app level default action is going to take effect. Now, if we want to change this a little bit and see how the global action works, then let's change this default action to say deny. And let's change the app name now. And now the verb level stuff should not really matter, but we can change it to deny to. So now in this case, now when we try to match the app ID, it won't match. So in this case, we will go and look at the default action at the global level. So now let's apply this configuration and see that it's still denied. So you still see this policy denied, and if we want to see the node app, it should not have gotten any messages from the Python side. So yeah, that's the demo. Any questions?
There was a question from Lynn from earlier. He asks, when would I use this over something like OAuth client credential flow? Yaron or Vinaya, do you want to take that?
Yeah, so auth client credentials are a totally different way of authenticating when you have an auth provider that's external, like, for example, Azure Active Directory or Facebook or Google, and you have scopes. And then once you have that authentication in place, you basically need to have your own application logic be the judge of which operation is allowed, and you need to have all that thing spill over to your application code, where with authorization policies in service meshes and also like this one, you can get just Dapr native mutual authentication, driving all of that for you without the need for an external auth provider. And you get configuration to basically specify whatever methods and trust domains you also get. Also with auth2, you don't have the concept of trust domains and namespaces. And really, it's tailored to service-to-service invocation inside a cluster or something that can even span multiple clusters.
Okay, great. I don't see anything else that was unanswered in the chat window. So with that, I guess we can move on to secret scoping, and Mukundan's going to speak to that. Take it away.
Yeah, sure, Ori. Thanks. Let me share my screen. Let me know when you can see it. Just a quick.
Nothing yet.
I would need to cut and reconnect the call. Just a minute.
Okay. So if there's any other questions in the meantime, happy to take them. If not, well, Mukundan reconnects. Let me actually share something as well. I don't know if you saw, but we recently also launched a Dapr blog. So we are going to be using that, and this is the blog. You can find it in blog.dapr.io, and I'll drop that link in the chat in a second. Right now, we just have the announcement of the blog itself, but moving forward, we expect to share some more news and announcements and the regular things you would expect, like maybe technical deep dives to specific things that are coming up. So we got a RSS subscription as most blogs, and so feel free to watch for that. We're kind of excited to have this additional channel to communicate with the community and share announcements and stuff. And I think with that, Mukundan should have joined, but I'm not sure he can share because I need to make him a presenter. So 1 second, please. Okay, Mukundan, you should be able to unmute and share right now.
Yep. Can you guys see my screen?
Yeah, we see it now.
Okay. So in the 0.11 release, we are adding a feature to limit the secrets that can be read from secret stores. So we already have the feature to read secrets from either the inbuilt Kubernetes secret store, or we have other components that it can read from, like Vault, or you can also define local secret stores and so on. So in this 0.11, what we are doing is we are also adding the feature to limit what secret can be read from which secret store. So this is again an enhancement to the configuration document, the configuration YAML that's added to the application through an annotation or through a flag during the self-hosted run. So for example, how the configuration YAML looks like with secrets is you would have the configuration YAML again defining the configuration name, and then from there you have the secret and then the scopes for those secrets. So where you can define multiple scopes. So in this example, what you're having is you have a scope with a store name as Kubernetes, and then a default access policy that's defined as deny. So in this case, what's going to happen is even if the Kubernetes YAML configuration is added to the app as a component, or for example, let's say Vault is added to the app as a component, the default access is denied, so you cannot access any secret from that particular secret store. But let's say you want to specify a particular list of secrets that you want to allow access to. For example, again, in this scenario, you want to allow access to secret 1 and secret 2, but you want to allow, deny access to all other secrets. You can still configure it in a fashion such that its default access is deny. And then you set the allowed secrets list as secret 1 and secret 2. So in this scenario, what would happen is both secret 1 and secret 2 are, is accessible by the app that is configured with this specific configuration, but all other secrets are then denied. So in a different scenario wherein you want to deny specific access to certain protected like certain secrets, so what you can do is you can probably allow access to the app for all secrets in the secret store, but then you can also deny certain secrets. In this case, secret 1 and secret 2 are specifically denied, but the app has access to all other secrets. So for the example demo, what I'm going to do is I've added the configurations to the well-known secret store quick start, and I'll be going through that in steps. So what we can see here is the config.yaml. So for this, what I have defined is a local secret store. So a local secret store component has been defined so that it can be run in a self-hosted mode. And in that we have two different secrets, my secret and random secret. So random secret is something that I've just denied by policy if I add it in the config.yaml. So as you can see, the local secret store that has been defined has the name as local secret store, and the config.yaml uses the same name for store name. And then the allow access, the default access is allow, but then the allowed secrets takes priority over allow, and essentially it is limited to my secret alone, and all other secrets are then denied. So let's have a quick demo of this one. So what I have in this app is pretty much two different endpoints for getting secret and getting the random secret. So getting secret is just getting the my secret key, and getting the random secret gets the random secret key. So I also have the secret store passed in as an environment variable. So what's going to happen here is I can basically run an export of the local secret store. And then here, if you see the call that's being made, I'm just adding the components in the components path, the components folder alone. I'm not specifying any configuration as such. So what would happen here is there is no configuration specified, and by default, what we have in the previous Dapr versions is we have access to the secret store because it's been defined in the component. It has been defined as a component. So that is what we are going to get here also. So here you can see we are able to get a base encoded version of that secret. And then again, if I get the random secret also, that is also going to be the same version as well. So the next one is if we want to add a configuration in the self-hosted mode, so we can have the config -config parameter. And with that, what is going to happen is we would be getting a permission denied error for getting the random secret. So if I try to get the secret, I'm still able to get that secret, that's fine. But then if I try to get the random secret, so what's going to happen is I'm going to get a 403 error, and that's pretty much basically denying my access to random secrets specifically. And this can be done for applications in Kubernetes as well. So in Kubernetes, what needs to happen is we need to add it in Dapr io/config as secrets config. And if you see the secrets config.yaml, it is similar, almost as similar to the local store configuration. Essentially, the store name alone is different here, and the name is different here. But what here we have is we have the default access as deny, and then allowed secret as my secret. So in this case, both the policies that I have shown, the config.yaml allow and then on my secret as allowed secrets, and default access as deny and allowed secret as my secret, both have the same, in the end they perform the same functionality. So they only allow my secret to be accessed by the application. So quick demo of that is essentially, first I create the secrets again. I'm calling it again random secret and my secret in Kubernetes. And then I can show you the rest of the things, right? So essentially I can deploy this thing. And then I'm going to deploy the node.yaml application. So I can deploy the node.yaml application. We can see that the container is creating, and once it's running, and what we can have is so by default you have get secret, which has the again the secret that you can see, and then the get random secret. So here, this is the normal application that you are having. So there is no policy that's been applied to this. So if you apply the policy here, again, I'm applying the secrets config policy that's been shown here, basically denying all access, but only allowing access to my secret. And as you see from the app.js, my secret is accessed via the URL get secret, and get random secret accesses the random secret. So once the configuration has been created, I'm just restarting the node app for the configuration to take effect. So once that's done, what I can do is just a quick minute. Yep. So once that is done, what you can see is again the same effect that it has. So get secret is fine, but get random secret, some other key, basically, we are getting a 403 error in that scenario, right? So this is pretty much what can be done with secret scoping. So let me know if you have any questions or comments.
Great, thank you, Mukundan. And yes, please ask your questions in the chat window, or raise your hand to be unmuted. And with that, we can actually go into the general open Q&A. So these are questions about anything really, whether it's the anything you saw today. And by the way, those two features, the secret scoping and allow list for service invocation, both are coming up in the 0.11 release that will be coming out later this week. So not yet available if you're using 0.10, but coming soon. And with that, I'm not seeing anything in the window. Oh, here's a question about the release. Is release 1.0 still anticipated in November? So the way we're kind of moving towards the 1.0 release, which is a production-ready release, is probably going to be through release candidates. So we do see that coming in the next couple of months around the November timeline. But we really want to make sure that you know, once we do get to version 1.0, it's really solid and stable. So we'll need to see how these release candidates kind of how many issues are found, and we're going to encourage the community to kind of test them out and try them out. And we expect to communicate more about that in the near future, possibly in the next community call. But definitely we see a release candidate by the end of the year, before the holidays.
Yeah, and Phil asked before if we have an open integration, and so I gave a link in the chat window. We do have an open policy agent middleware now, where Dapper basically hosts the open policy agent rules engine, which is really nice because you can write the Rego expressions for open policy agent in the middleware itself. And you can scope it to specific applications because our scoping feature works for all of the components. And then you can do some really cool stuff with it. So, you know, in regards to, for example, authorization policies, you might have something like the access list work on the identity of the workload. And then after that, you can have specific rules that target things like headers or even the content of the incoming request, and applying the OPA policies on top of them. This is just one example. There are basically hundreds of them. So check out the open policy agent integration because that's pretty powerful.
Yeah, and I see another question from Andrew about kind of if you want to contribute, how to set up the debug environment and stuff like that. So currently you can find that in the runtime repo, which is just named Dapr. So under the Dapr organization, Dapr, there is a there's links. There's a doc section there that talks about kind of developing for Dapr and how to set up the environment and all that. We do also, one of the plans that's going to come up in the next few weeks, hopefully, is we are going to create a docs experience that's more of a web experience, kind of like a website for the docs. It's going to be compiled from from the general docs repo, but we are planning to make the developer documentation also be part of that. So hopefully that'll be easier to find. But right now, and we can drop a link in a second. Right now, there's you can just find them in the Dapr repo under docs. There's a bunch of readmes there about setting up the environment, how to build Dapr and all that stuff. And please, if you want to contribute, please check also the contribution guidelines. And we also have some contributing readmes as well in there. And another question about 0.11. So 0.11, we expect it to be released later this week. So we really are in the final stretch of getting that release ready and kind of testing everything, making sure everything that is planned in there goes in there. You can actually see the 0.11 release or any other milestones that we keep track of in the projects side. So if you go into the Dapr organization on GitHub and click projects, you're going to see a 0.11 release. For that one specifically, you're probably going to see a lot of stuff already in the done column. So that's going to be a Kanban board of that project. But you can kind of see how it moves along. And you can also, in the future, if you see from the next releases, we invite you to contribute and pick up, any issues that you can contribute to. If you're just starting out, we do make an effort to use the GitHub label of good first issue. But if you're more knowledgeable and you've contributed before, or you feel you can contribute, then obviously any other issue is great. We do try to prioritize them as well and kind of keep good labels on which area of Dapr they address, whether it's a building block or security or testing or any of those. So we'd love to see more contributions from the community, as well as issues, of course, as always. So another question from George. How many developers are working on Dapr now? So it's funny, we just had a conversation about that. So we're seeing, actually, in terms of overall contributions that include opening issues and PRs and everything, we see around 500 people, over 500 people, I think around close to 550 from the overall community. So that's awesome. It's been steadily growing, really month to month. So some people are contributing more, obviously, and some people are less. We do have a few people who are, 100% on the project, which is great. A lot of them have been presenting in these calls, but it's great to see any contribution, even just fixing. In the chat, we just had like a small discussion on fixing even a small typo in the docs. Even that is a great contribution. So we really appreciate all that. And with that, I think we will end this meeting. We're at time. Oh wait, there is another question from Andrew. Are there any MS projects leveraging Dapr, like something in Xbox or Office 360? So I think you mean Office 365. Hopefully it's the whole year. Yeah, so there are definitely some teams inside Microsoft that are looking into Dapr. We definitely hear about that a lot. But yeah, I don't know if there's anything we can share at this point. One more question from Monty. Any feel for non.netters taking notes? I'm not sure I understand that question. Can you clarify?
Do you mean if there are non.NET users for Dapr, or what's the question really?
Oh, if we see things from other communities, yeah, absolutely. We do see other users of Dapr contributing. Don't know if we have exact numbers of that, but definitely outside of Microsoft for sure.
Yeah, and I'm personally talking to a lot of people on Gitter. A lot of them also are running Dapr on platforms like AWS, for example. Great.
Plus, we've seen contributions from like partner technologies, things like HashiCorp contributed stuff to the components contrib. We're seeing really across the board. Like as I said, we've seen it's over 550 people that have contributed to some extent, and yeah, a lot of that is coming outside of Microsoft for sure. And that's our goal, by the way, to really make this open. This is not intended to be a technologies just for .NET or whatever. And you can see that in the work we do in the SDK as well. And even some of the demos you see here are really not just .NET. Okay, thank you. And we're past time, and I want to be respectful of everybody's time. Thank you for this. Feel free, if you have more questions, to find us on Gitter, to open issues on GitHub, make proposals, pick up PRs, all that good stuff. And of course, continue coming to these community calls that we have every 2 weeks. So thank you very much, everybody.